सो हेलो एवरीवन। आज हम इलेक्ट्रोकेमिस्ट्री का लेक्चर नंबर 2 करेंगे। लास्ट लेक्चर में मैंने किया था कि व्हाट इज गैल्वेनिक सेल, वोल्टेइक सेल के बारे में हमने किया था पूरा। ठीक है, आज का जो हमारा टॉपिक है उसमें हम करने वाले हैं नर्स्ट इक्वेशन। दैट इज वेरी वेरी इंपॉर्टेंट फ्रॉम द एग्जामिनेशन पॉइंट ऑफ व्यू, और उससे आपको क्लियर होंगी चीजें रिलेटेड टू क्योंकि नॉस्ट इक्वेशन से एक एक क्वेश्चन तो एग्जाम में आता ही आता है। ठीक है, तो अगर वो कर लेंगे हम, हमारा एक पार्ट जो है कवर हो जाएगा। ठीक है, तो लेट्स स्टार्ट। यस बेटा, तो आप जरा एडजस्ट करने दो मुझे। वेट, इट्स फुली एडजस्टेड नाउ। तो आप, क्या नाम है, एक मिनट बेटा, वेट। यस बेटा, ओके, कंटिन्यू करें। श्री, आर यू हियर? Let's start today's session, and it is going to be very interesting and very very important. So Nernst equation. The Nernst equation actually it is used to measure cell potential, or we can say sometimes electrode potential at any concentration. And formula used is like, let us say we have this reaction. This is reduction reaction, to write Nernst equation for this reduction reaction, it is electrode potential, or we can say reduction potential of this particular metal is equal to standard reduction potential minus RT over NF, natural log of product over reactant. Natural log of product over reactant. So what is product? Product is M solid and reactant is Mn positive aqueous. So this is one part of Nernst equation. We can write according to Nernst equation, E Mn positive M is equal to E naught Mn positive M minus RT over NF, natural log of M solid concentration divided by Mn positive concentration. Now, what is E Mn positive M? It is reduction potential of metal M. Okay, and what is E naught Mn positive M? It is standard reduction potential of metal M. Now what is R? R is gas constant and its value is 8.314 joule per Kelvin per mole. And T is temperature in Kelvin, and generally temperature is taken as 298 Kelvin. That is standard temperature. Standard temperature means standard state of metal. So in standard state of metal, temperature is considered as 298 Kelvin. And F is Faraday. Its value is very close to, is not equal to, but very close to 96500 coulomb per mole. So it is a charge on 1 mole of electron. And N is number of electrons gained or lost, or we can say number of electrons exchanged or transferred in the particular reaction. Now convert natural log into common log. What we do? Tell me. Convert natural log into common log. Keep in mind, to convert natural log into common log, we have to multiply by 2.303. Multiplied by 2.303. So it can be written as E Mn positive M is equal to E naught Mn positive M minus 2.303 RT divided by NF log of M solid over Mn positive aqueous. So Peter, this M solid, keep in mind concentration, or we can say activity of pure solid or pure liquid, it is taken as unity. Is concentration of pure solid, so it is taken as 1 Okay, and what is Mn positive in square brackets? It is the concentration of Mn positive ions in solution, in aqueous solution, right? Now the next step, E naught Mn positive M, that can be obtained from the electrochemical series, where all the standard electrode potentials, standard reduction potentials are given. Okay, and it is on the hydrogen scale. Now if we put the values, value of R is 8.314 joule per Kelvin per mole, joule per Kelvin per mole, and temperature as 298 Kelvin, N as such, and value of F 96500 coulomb per mole, log of, because M solid is taken as 1, so 1 upon Mn positive. So in this way, E Mn positive M is equal to E naught Mn positive M minus 0.0591 divided by N, which is very close to 0.0591. Okay, it's not exactly equal to 0.0591, but as a rule it is written as 0.0591, and in calculation sometimes we can write it as 0.06. Okay, so this is the overall Nernst equation for an electrode. For electrode potential of metal M or element E. We can write element M or metal M. Now let's write Nernst equation for a cell. Let us say we have a reaction, A moles of A react with B moles of B. N electrons are involved in this redox reaction, and C moles of C and D moles of D. So for E cell, according to Nernst equation, E cell equal to E naught cell minus 0.0591 by N log of product of the concentration of products over concentration product of the concentration of reactants raised to power their stoichiometric coefficients. C raised to power C, D raised to power D, A raised to power A, B raised to power B. This is Nernst equation for a cell. Now what is E cell? E cell is E right minus E left, or E cathode minus E anode. E naught cell is E naught right minus E naught left, or E naught cathode minus E naught anode. What is E cell? It is cell potential, or we can say EMF of the cell. EMF, electromotive force for E naught cell, standard EMF of the cell, and N is the number of electrons gained or lost. And what is C? C, A, B, C, D. A in square brackets, B in square brackets, C in square brackets, and D in square brackets are concentrations of reactants A and B and products C and D respectively. Okay, so this is overall Nernst equation. We can write like this. I will write few redox reactions and their Nernst equation. Like let us suppose we have this equation: zinc solid plus copper 2 plus aqueous to give zinc 2 plus aqueous plus copper solid. So first tell me, what is the value of N in this particular cell reaction? Yes, beta. Now it's your turn. Tell me, what is the value of N for this particular reaction? Fast to answer. So in this particular reaction, value of N is, see, how do we calculate the value of N? Is zinc to zinc 2 plus. So how many electrons are involved? 0 to plus 2. Change is of 2, and plus 2 to 0. Change is again of 2. So N for this particular reaction is 2. N is equal to 2. So E cell equal to E naught cell minus 0.0591 for N. Okay. Place of N we will write 2 log of product. Solid we will skip. Copper solid, zinc solid, it is taken as 1. So zinc 2 plus divided by copper 2 plus. And what is E cell? E naught cell first. E naught cell is E naught cathode minus E naught anode. So what is cathode here? Copper or zinc? Yes, beta. What is cathode in this case? What is cathode? Copper or zinc? At copper, reduction takes place, and at zinc, oxidation takes place. 3. Copper 2 plus to copper, there is a decrease in oxidation number, and that is called as reduction. That means copper is cathode and zinc is anode. So copper minus zinc. Standard reduction potential of copper minus standard reduction potential of zinc. And what is E cell? That is E of copper minus E of zinc. And zinc 2 plus in square bracket means concentration of zinc 2 plus ions. Copper 2 plus in square bracket means concentration of copper 2 plus ions. Okay, that's it. So this is one of the reaction. Now one more reaction. Copper solid, Ag plus to give copper 2 plus Ag solid. First balance this equation. See, copper to copper 2 plus is a change of 2, copper 0 to copper 2 plus. Now for as electron or decrease in oxidation number, sorry, increase in oxidation number for copper, increase in oxidation number by 2. So decrease in oxidation number should be 2. Here Ag plus to Ag changes of only 1. Decrease in oxidation number by 1. So we have to multiply it by 2 to balance the equation. To balance a redox reaction or an ionic equation, atoms and charge both should be balanced. Keep in mind, if I will not write 2 here, even then atoms are balanced. Copper 1, copper 2 plus is copper is 1 only. Ag plus Ag, Ag is 1 on both sides. So atoms are balanced, but charge is not balanced. If 2 is not there on either side, both sides, there is total 1 plus charge, and on the right side there is total 2 plus charge. So to balance the charge, we have to multiply silver by 2. So now on both sides there is plus 2 charge. 2 Ag plus, that means 2 plus charge on the left side, copper 2 plus. So total 2 plus charge on the right side. So charge as well as atoms should be balanced. Now let's write its Nernst equation. Now to write the Nernst equation, E cell is equal to E naught cell minus 0.0591 over 2. Again it is 2 because copper to copper 2 plus, there is a change of 2 electrons, or there is a loss of 2 electrons. Now 2 Ag plus 2 Ag, there is a gain of 2 electrons, right? So log of product copper 2 plus raised to power 1 only, because copper 2 plus number of moles are 1, but in Ag plus it is raised to power 2, because Ag plus ions, the balanced equation are 2. So this is overall Nernst equation for this particular reaction according to Nernst. Now E naught cell equal to E naught cathode minus E naught anode. So E naught cathode. So tell me, what is cathode here? Cathode. This reaction silver or copper, which one is cathode? Fast. Write in the comment section. Is cathode copper or silver? Yes, fast. No idea? So I will give you an idea. It is obviously silver, but we will write it like this: E naught Ag plus 2 Ag. Now, no need to write 2 Ag plus 2 Ag, okay? Minus E naught copper 2 plus 2 copper. So this is E naught cell, not silver minus E naught copper. Okay. So now one more zinc solid plus chromium 3 plus zinc 2 plus chromium solid. First balance this equation. Yes, beta. To balance this equation, what we do? The atoms are balanced, but charge is not balanced. On left side, charge is plus 3. On the right side, charge is plus 2. To balance the charge, what we do? Tell me. Okay, tell me what we do to balance the charge. Yes, beta. To balance the charge, we multiply zinc by 3 and chromium by 2. What is N here? Tell me, what is N? You are not answering the questions. Yes, beta. Tell me, what is the value of N in this reaction? See, just look at the one equation, one atom, zinc. Zinc 2 plus is formed from zinc. So obviously, there is involvement of 2 electrons. 2 electrons are lost, and there are 3 zinc. So we multiplied by 3. So 3 Zn solid gives 3 Zn2 plus 6 electrons. That means N value in this particular redox reaction is 6. N is 6. And according to Nernst equation, E cell is equal to E naught cell minus 0.0591 divided by 6 log of think 2 plus raised to power 3 divided by chromium 3 plus raised to power 2. Think 2 plus raised to power 3 divided by chromium 3 plus concentration raised to power 2. And what is E naught cell? E naught cathode minus E naught anode. Okay. Okay. E naught cathode minus E naught anode. Now, from the E cell, we can calculate delta G. Delta G is related to E cell by this equation. Delta G equal to minus NF E cell. Very good, Khushi Srivastava, Kunjan Kumari, great. That's what is expected. Minus NF E cell. What is delta J? Delta J is gives free energy. So gives free energy is related to E cell by this equation. Delta G equal to minus NF E cell. And you know number of electrons transferred in a redox reaction. And F is Faraday. Faraday is the charge on 1 mole of electrons. E cell is EMF of the cell. And delta G naught equal to minus NF E naught cell. NF E naught cell. Right? This is about delta G gives free energy. We can calculate by using this equation. So you can see if E cell is positive, then delta G is negative, means redox reaction is spontaneous, means feasible, means it takes place by its own. Now at equilibrium, see A moles of A react with B moles of B using n electrons. Let us say this is a redox reaction, C moles of C and D moles of D. So in this particular reaction, E cell is equal to E naught cell minus 0.0591 over n log of product over reactant. Okay. Now, before equilibrium or at any concentration, any time of the reaction, this ratio of the product to the reactant is called QC, that is reaction quotient. But at equilibrium, QC is equal to KC. That is, AC means equilibrium constant, and at equilibrium E cell is equal to 0. EMF of the cell or E cell is 0 at equilibrium. So that means this equation becomes E cell is 0, E naught cell minus 0.0591 over N log of Kc. That implies E naught cell equal to 0.0591 over N log of Kc. So E naught cell is related to the equilibrium constant by this relation. Naught cell equal to 0.0591 over N into log Kc. Okay, beta. So these are the final 3 equations that we have to use while solving the numericals. Most of the numericals in electrochemistry, these are 3 equations which are very, very useful. First is Nernst equation for any reaction like this. Cell equal to E naught cell minus 0.0591 over N log of C raised to power C, D raised to power D, A raised to power A, B raised to power B. And second equation is calculate Gibbs free energy. Nernst equation is used to calculate the EMF of the cell, and calculate Gibbs free energy. Equation used is delta G equal to minus NF E cell, and third is relation between E naught cell and equilibrium constant. So that is E naught cell equal to 0.0591 over N log of Kc. So keep in mind these 3 equations. By using these 3 equations, we will solve numericals tomorrow. So be ready. Tomorrow I will use these equations to solve the numericals. Let's have a class tomorrow, most probably in the morning. 9:15 to 10:15 I'm busy, so maybe in the evening as well. Okay, thank you so much, all of you. Bye. Do subscribe my channel if you have not subscribed yet. God bless you all.